Assalamu alaikum. My name is Ali Zahrani, and my teammates are Muhammad Abu Saud, Muhammad Al Badin, and Ali Al Kharz. And today I will give you an introduction about our presentation about differential motors. I will start by talking about the project definition. The report focuses on the design and fabrication of electric motor and differential systems for the electric car. Electric motor is the heart of the electric car, which gets its power from the controller, and the controller gets its power from the battery. Electric motor drives the car with low voltages. Electric motor also replaced with combustion engine, which is emission-free automotive. And there are various types of electric motor used for electric vehicle given below, such as the DC series motor, brushless DC motor, and so on. Next, we have the next objective of our project is to design and fabricate the electronic differential system for the electric car. The working of the electronic differential is working based on the input and output parameters to control the right and left speed of the vehicle. Electronic differential system gets input from the throttle speed and the steering sensors, and it gets the output from the vehicle wheel right and left movement. This is a proposed electronic differential structure. We can see the control system where the DC and the inverter and the motor and the reference, which is the speed, and the controller, of course. The project objectives to study the electronic or the electric vehicle components like electric motor and differential system of the electric vehicle, design and fabrication of electric motor for electric vehicle, design electronic differential system for electric vehicle directly driven by dual induction motor wheel and the rear wheel, to construct the electronic differential system for electric vehicle with low cost. The power specifications or project specifications. There are various types of electric motor and electronic differential systems used for electric vehicle, but the schematic diagram and design specification of electric motor and electric differential system used for in this project are shown in the next figure and table. You can pause the video at any point to look at the table. This is table number 2. Finally, this is a schematic of a differential motor, electronic differential motors. And in our project, we have decided that we will put the motor in the rear wheel system instead of the front wheel system. Thank you very much.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Hello everyone. My name is Muhammad Al Badin. My ID is 2014-02546. I am member of group 2, differential motor. And I am going to present the project's background, application of electric motor and electronic differential system, and comparative study. First of all, project background. Our task is to design system for car A, which is supposed to be differential system. That system is similar to daily cars that we are used. The mechanism we choose is direct connect the rear AC motor to the electronic differential and the rear wheel drive car. As you see on the figure, that our design of placement for the motor on the rear side of the car to secure that will not losing any energy by transfer from motor to the differential. Secondly, application of electric motor and electronic differential system. Solar vehicles are rarely used worldwide due to it's not applicable for some weather conditions and its high cost vehicles. AC induction motor mainly used in automobile due to its high efficiency, good speed regulator, and absence of commutators. Commutators is part to reverse the rotation of motor used on DC motors only. about electrical differential system used in automobile system in place of mechanical differential system. Electronical differential system requires torque to each vehicle wheels and allows various vehicle wheels speed electronically. For example, it splits the torque and speed between the two tires on the turns. They give internal tire speed more than outer tire, and that happen by task from the controller. That's a good advantage for electronical differential system. Thirdly, comparative study. There are rich literature present in the field of automotive world present by several researchers, but there is a few literatures have presented about solar vehicles and their projects various component modification. In this project, design and fabrication of electric motor drive and electronic differential system is presented for solar vehicles. The appropriate design model and fabrication technique is presented in the study, which is best for solar vehicles as well as economical and reliable. Thank you for listening. I will let my colleague Muhammad to complete.
Assalamu alaikum. My name is Muhammad Abu Saud. My ID is 2015-01-686. I am a member of Group 2, which is Motor and Differential System. I will talk about Part 1 in Chapter 3. Chapter 3 is System Design, and Part 1 is going to be Design Constraints. First, I will talk about geometrical constraint. For electric motor and differential system to be effective and efficient, we need to reduce the weight as much as possible. As for our project, we assume that the weight will be around 600 kg. This means that the maximum weight the motor will stand is 600 kg, and the motor will be more powerful if the weight is less than 600 kg. Next is going to be sustainability. The motor we select has to be supportive to climate and surrounding. This means that it has to be able to work in all 4 seasons and during harsh weathers such as sandstorm or raining. Also, the motor we select has to be able to reach 80 km per hour and maintain this speed without any problem. Next, I'm going to talk about environmental concern. This project is environmentally friendly. It has no air pollution, as the main source of its energy is solar energy, which is abundant in Saudi Arabia and wasted by the majority of people. Next, I will talk about economic. Electric cars are more expensive to buy than internal combustion engine cars, but they are cheaper to maintain. Even the spare parts are still not cheap and not easy to find at the current time in Saudi Arabia. That's why we have been struggling to find a suitable motor for our project locally. However, we found many suitable motors for our project online. The government of Saudi Arabia is promoting solar energy as part of 2030 vision of the kingdom. That's why in the near future we will have more and more stores regarding solar energy, which is going to make it easy for us to find spare part. Last thing I will talk about is safety. For the safety part, we are concerned about avoiding slipping during high speed. That's why it is preferable to use gear and chain instead of belt. Also, it is important to make sure that the motor does not heat up because that will reduce its performance and might cause problems. Thank you for my listening. This is my part.
Assalamu alaikum, my name is Ali Al-Khars, ID 2040-03365, and today I will be talking about the second part of chapter 2, which is about system design. In this presentation there will be many tables, so please feel free to pause at any time. First thing, engineering design standards. For any system to have a strong foundation in the engineering, it must have followed and applied the engineering standards. The engineering standards followed are given in the table below. Subsystems and components. Following the table shows the dimensions of some of the components of the electric car electronic differential system. Brushless DC motor. A brushless DC motor, also known as a BLDC motor, is an electronically commutated DC motor which does not have brushes. The controller provides pulses of current to the motor windings, which control the speed and torque of the synchronous motor. Electronic differential. An electric car differential is used along with a single motor to take up the motion responsibility of the rear wheels, as there is no mechanical combustion engine in electric cars. Electronic differential is advancement in electric vehicles technology, as it is the mechanical operative of the electric car connected to electric controller. Its task is to provide the required torque for each driving wheel and allows different wheel speeds electronically. It is used in place of the mechanical differential in multi-drive system. Power requirements. As this whole project depends on the electric motor and electronic differential system, it is mainly reliable on power source and power generation. Following are the power requirements. Manufacturing and assembling. The said project is working on the brushless DC motor, which takes up the load of the car, and another important component of the electric car is the replacement of the regular combustion engine, which is differential. The differential's task is to perform the mechanical gear action as it is attached to the axle of the rear wheels when cornering. The inner and outer wheels rotate at different speeds. Because the inner wheels describe a smaller turning radius, the electronic differential uses the steering wheel command signal and the motor speed signals to control the power to each wheel so that all wheels are supported with the torque they need. This keeps the speed of the car in control and provides with good grip of tires on the road. Battery is very essential part of the electric car, as it's supposed to be taking the load of the whole car, not just starting the engine. It continuously provides the electric power to the DC motor of the car to keep it running. So there are a number of lithium batteries will be used in the electric car. Thank you.